Buildings and architecture, the most familiar shelters in our daily life. By defining the boundaries of indoor and outdoor, they organize the space functions, present distinguished styles, and change the landscape. Underneath the surface of each building, the geometry primitive and their assembly outline the silhouette of architecture and partition the inner space. But at urban scale, how the choice of geometry primitives and their assembly influence our life is still not clear. The wealth of three-dimensional architectural data has unlocked the great potential for shape analysis of buildings at urban scale. However, shape analysis of buildings from the off-the-shelf 3D data could be very challenging. We proposed a method based on the decomposition and reassembly of buildings for the shape analysis. Here is the pipeline of our method, which is based on mature computer graphics techniques and in-house max-convex decomposition. Our study area is a part of Chim Sha Choi. The source data are the 3D building instances released by Lands Department. Here are the results of building decomposition, which are colorized based on the decomposed components and buildings. We then assembled the components by their topological relations to form a graph for each building. Inspired by the graphlet concept, the subgraphs and the building graphs are counted. Their frequencies serve as the feature vector of each building for the following clustering. Here are the clustering results. Simple graphs are prone to be clustered in a group, while complex graphs hold a higher level of diversity. We then visualized spatial distribution of the building clusters on the map and conducted a spatial autocorrelation analysis. The result indicates that the distribution may not have been formed by random. By hot-cold spot analysis, one group of cold spots and 3 of hots can be observed. By co-visualized the spot analysis in 3D buildings, we found that the cold spots are corresponding to a more consistent arrangement of simpler building blocks compared with their surroundings, while the hot spots are raised by the aggregation of complex buildings with simple neighborhood buildings. Therefore, our pilot experiments show that the decomposition, reassembling, clustering, and spatial analysis framework for building shape analysis can identify building spatial patterns in an effective and innovative way. Greater potential of our framework will be explored more in the future. Thank you for watching.